Welcome to the course of Basics of Cloud Computing. Before moving forward, we should know why there is a need of cloud computing. Let's understand this with an example. And for this, we need a busy person. Let's name her Katie. She is the CEO of a small company having 20 employees. She works very hard to take her company on the top and her employees too. For the growth of the company, they need the IT support function. But as her company is too small, they don't have their own IT guy, and hence they have to hire an external IT consultant. And this IT consultant provide her company with software, database, backup system, network, storage, and customer-based web application. And now she get very frustrated, because most of the investment are going in the IT support function, and due to this, her company has to suffer losses from all this IT investment. So one day she got an idea. She thinks most of the daily stuff are online, just like we watch the videos online, we chat online, and we hear the music online. So why shouldn't her business do the same? And then her company moved to the cloud computing. Like this, everything is stored and saved at a secured place. All it needs to access it is just a simple web browser. And that's what we call the cloud computing. That's put your work over the internet. And this will help her to save the money instead of giving it to the IT expert, and this will make her company grow. Finally, Katie can give her time to her family and feels free. Wherever she is, everything is just on the one click. And that's what cloud computing does for their consumer. And now, from this example, I think you can better understand why there is a need of cloud computing. And here, I have created the course of Basics of Cloud Computing. And in this course, we will learn pointwise about which are the various service models, cloud computing deployment model, about the service provider, hosting scenario, and many more. If you like this content, do join with me in this course. So see you there. Thank you. With the massive growth of data and increasing complex IT challenges, organizations are looking for the new way to modernize IT. To take advantage of data backup and disaster recovery, virtual desktop, software development and testing, big data analytics, and customer-facing web application, organizations look to cloud computing to modernize with proven solution. And here, I have created the course on Basics of Cloud Computing. Before jumping in the course, we should know why cloud computing. Let's look at what IT does to an enterprises. IT is just like a support function for any business. The business may be of tire manufacturing or rocket engine making, needs the IT support function, and they invest heavily in deploying the machines, setting the data center, networking, storage, and many more. In order to maintain such infrastructure, you need specialized skill which is hard to find in the IT industry. So all this, taking your focus to the IT support function instead of your core business, which is tire manufacturing or the rocket engine making. All the investment are going in this IT field. So organizations are looking for the way to overcome this support function. And there comes the cloud computing. Cloud computing is an on-demand of IT resources over the internet. Instead of buying, occupying, and maintaining physical data center and server, you can access the technology services such as computing power, storage, database, which are provided by the cloud providers like Amazon Web Services, Microsoft Azure, Google Cloud Platform, and many more. The way it offers to the customer is just like a service. For example, just like electricity, you consume electricity, you pay for it. You consume cloud services, you pay for it. And if you don't consume anything, you do not need to pay anything. And hence, organizations of any size, any type and industry using cloud computing for wide variety of use cases. Cloud computing has three different dimensions such as software as a service, platform as a service, and infrastructure as a service. due to which cloud computing gives you instant access to the broad range of new technology so that you can innovate faster in the field like machine learning, artificial intelligence, Internet of Things, and many more. Cloud computing changed the whole game in business model, and it allows the businesses to go back to their core business, which is tire manufacturing or the rocket making, instead of worrying about the IT services which are already provided by the third party. And now, if you are excited about the cloud, join this journey with me of cloud computing. Thank you. Topic: Infrastructure as a Service. Here in this lecture, we will going to see about infrastructure as a service, which is one of the cloud computing model. And the infrastructure as a service, or IaaS, is a form of cloud computing that provides virtualized computing resources over the internet. The cloud service provider provide infrastructure as a service which helps the customer to access and monitor stuff like computer, networking, and other services just like virtual server, desktop, security, and many more. In the IT infrastructure, it involves efforts that require large amount of investment to deploy, maintain, and upgrade their services. And therefore, for the small size of firms, it is very costly to handle such services. And hence, with the help of infrastructure as a service, it is possible for any size of firm to have the same infrastructure as any large firms have. Infrastructure as a service delivers fundamental compute, network, and storage resources to the customer on demand over the internet and follows the pay as you go basics. So, the pay as you go basics means customer has to pay for what they have used. One of the business benefit of infrastructure as a service is that it can scale up or down as per the demand so that the customer does not have to pay any extra charges. In the infrastructure as a service, the user does not need to have their own premise data center and does not have to worry about the physical updating or maintaining these components themselves, as it is provided by the infrastructure as a service. Infrastructure as a service approach uses virtualization to maintain the consistency of the services. With the virtualization, it is possible to manage hardware like a software. Here, in the infrastructure as a service, it involves application hosting, and for this, it provides virtual server for the application hosting. And the infrastructure as a service offers runtime server that can be deployed or scaled up as per the need. And this is very important stuff which is offered by the infrastructure as a service that offers the runtime server. The application hosting can be for the native, web, or mobile application as per the use of the consumer. It also provides the approach which is used for the backup and storage. For enabling the data backup and recovery, infrastructure as a service provide environments, disk space, and memory, and the resources for the data backup can be deployed as per the need of the customers. Here are the several examples which provide infrastructure as a service, which are Amazon Web Services or AWS, Microsoft Azure, Google Cloud Platform. And here we have some of the advantages which is offered by the infrastructure as a service. So first, protection and recovery. Protection and recovery of the data is very important aspect. It can be seen that for achieving continuity and disaster recovery is very expensive for the organizations, and hence organization required more staff and new technology. So this advantage is provided by the infrastructure as a service provider, although it seems to be very costly. Second, rapid innovation. During the launch of new product, The computing infrastructure have to be ready within the minutes or the hour rather than on the days or week. So this advantage provided by the infrastructure as a service that the all services can be ready within the minutes or the hour. Third, flexible in every business condition. Infrastructure as a service helps to quickly scale up the resources and make it flexible as per the demand. When the resources are not in the use, the resources are backed down to save the money. Fourth, better compatibility. In the infrastructure as a service, there is no need to maintain and upgrade software and hardware or to troubleshoot the problems as there are very fewer compatibility issues with it. So these are some of the advantages which are provided by the infrastructure as a service. See you in the next lecture. Topic: Platform as a service. Platform as a service or PaaS, or you can call it as a PaaS, is a form of cloud computing where hardware and application software platform are provided by the third party. For developers and programmers, it provides a platform and environment to build application and services. If you are a programmer, you write the code, build and manage your application, but here you do not have to worry about the software update and hardware maintenance, as the environment to build and deploy is provided to you by the platform as a service. It delivers top of the line development frameworks and tools so that you can launch your program and services at the higher level. Platform as a service not only includes server, storage, networking, which were provided by the infrastructure as a service, but also database, tool, business services, and many more services. To host the customer's application, the provider or the third party provide functions such as the server, storage, database, tools, and all. The customer has to take care of the deployment of the software with most of the configuration which are handled by the provider or the third party. It is obvious that the service is hosted in the cloud and accessed by the user over the internet. For the services and application, platform as a service enables to deliver simple cloud-based application to the higher cloud-enabled application. During the launch of new product, cloud infrastructure needs new upgradation and new features to be added. So, platform as a service are constantly updated and new features are added to their services. Platform as a service follow pay-as-you-go model. As said earlier, you have to pay as per your uses. So, due to this, firms of any size can implement environment that can match their need, and there is no need for the large investment for configuration and maintenance of the software. Platform as a service business advantages include lower cost, expertise, and lower overhead investment and efforts. So, due to this, platform as a service enables geographic around the clock development using the same investment. Platform as a service provides multiple operating system development at the same cost. Here are some examples of the platform as a service: AWS Elastic Beanstalk, Google App Engine, Apache StarTools, Windows Azure, and there are many more such as Force.com, Heroku, and all. Advantages of platform as a service. First, reduces the coding time. With the help of platform as a service, the coding time reduces with the time it takes to code new apps with pre-coded application part designed into platforms like workflow, directory services, security measures, and all. Available at multiple platforms. It can be accessed from many devices such as mobile, tab, laptops, and many more. In addition, some of the service provider offers development choices from multiple platforms like computer or browser, creating cross-platform app faster and easier to develop. Enhances the development capabilities. Platform as a service parts will provide your development team new capabilities while you do not need to add the workers having specified skill, as all is provided by the platform as a service tools at economical cost. Platform as a service provide pay as you go model, as said earlier, which make it potential for organization to use subtitle development package and business intelligence or analytic tools that may not be afford to get override. So these are some of the advantage which is provided by the platform as a service. Now see you in the next lecture. Topic: software as a service. Software as a service, or we can call it as a SaaS, is a cloud computing model where third party provide application for the purpose of offering them to the customers over the internet. In software as a service, software is provided by the third party. They host the application and maintain the application, and then they offer it to the customer over the internet. SaaS is the most familiar variety of cloud computing to all users, specifically in the field of business. SaaS is on-demand computing software delivery model and closely related to the application service provider or ASP. SaaS is similar to application service provider where the provider hosts the customer software and deliver it to the approved end user over the internet. Actually, in the SaaS, most of the stuffs like application, data, runtime, storage, networking, and many things are under the control of the third party. It is not under the control of yourself, means the consumer. SaaS delivers enterprise software on the subscription basis. You have to purchase the software or the services on the subscription basis. SaaS has a large market not only with the corporation but also with the consumers. SaaS offering is very common, especially accounting, conferencing, meeting tools, or time tracking, payroll software are just common thing which is provided by the software as a service to the consumers. SaaS terminates the need for business to install, host, and maintain the software products. SaaS allows the model which is much more efficient and firms have to pay only for the software that they used. SaaS delivers expertise and support. In case of technology advances, SaaS make it possible for the firms to have access to the more technology. It is one of the common delivery model for many business applications such as office software, messaging software, payroll software, and many more. Here are some examples of software as a service. Office 365, which is office software, Gmail, which is messaging software, Paycom, which is payroll software, and many more services like Google Apps, Salesforce, and many more. Here, we have some difference between infrastructure as a service, platform as a service, and software as a service in terms of on-site services which you can manage or the service provider can manage. So, in the blue one, the services that you manage, and in the red one, the services that provider manages. Let's see the infrastructure as a service. Application, data, runtime, middleware, OS is managed by you or the consumer. And others like virtualization, server, storage, and networking is managed by the service provider. If you see in the platform as a service, you have very lesser thing to manage. Application and the data is under control of yourself, and all other stuffs like runtime, middleware, OS, virtualization, server, storage, networking are under the control of service provider. And if you see software as a service, then you do not have any control on the services. Everything is under the control of service provider like application, data, runtime, middleware, OS, virtualization, services, servers, storage, networking. All the stuff are under the control of service provider. So we have seen some basic difference between infrastructure as a service, platform as a service, and software as a service. So see you in the next lecture. Topic: function as a service. In the previous lecture, we have discussed about the different service models like infrastructure as a service, platform as a service, and software as a service. Now, we will discuss about function as a service. Function as a service is much more different from other service model in the way of implementation of the services provided by it. Function as a service is much more identical to platform as a service. It can offer same services that platform as a service can offer. Function as a service provides application development services in the form of microservices so that the service price is much low. Function as a service is different from the platform as a service in the way of providing computing services dynamically on demand. In function as a service, customer only pays for the time that services is used. Not like the other services where you have to take the services on subscription basis, and that subscription basis is maybe for the days or weeks or the month. But here you will have to pay only for that time that you use the services, and if you close the access of services you won't be charged. Hence it offers runtime services. Function as a service provides the processing data and they do not store the data. As said, services stop during idle time. Customer do not need to give any cost during the idle time. As customer closes the access to the services, customer won't be charged. Not like the other services where you take the services on the subscription basis and you will be charged accordingly for days or week. But here you will have to give money only for the time that you use the services, and for the rest of the time you won't be charged. Function as a service is also known as serverless computing. And in serverless computing, the cloud provider manages the computing resources in the way that they can be delivered in a dynamic fashion. And about the serverless computing, we will study in detail in the further lectures. Function as a service protect customer from underutilization cloud server. In function as a service, the services are provided by the third party and which makes the customer to be dependent on the cloud provider. And we may call it as the drawback of the function as a service. Here, Security can be the issue if the cloud provider do not take the necessary step to guard the data. In the function as a service, customers' data is under the control of the cloud provider, and therefore there will be less ability to move away your data from the cloud provider. Here we have some example of function as a service: AWS Lambda, Azure function, and Google function. See you in the next lecture. Topic: Public Cloud. In the previous lectures, we have discussed about cloud computing models, and now we will going to study about cloud computing deployment models. So first is public cloud. Public cloud is defined as computing services offered by the third party over the public internet and making them available for anyone who want to access or purchase them according to their needs. The public cloud is a set of hardware, networking, storage, services, application, and interface which are owned, run, managed, and operated by the third party. In the public cloud services, they follows pay-as-you-go model, or it may be free depend on the variety of subscription which is provided by the providers. In public cloud, providers offering storage or computing services optimize their computing hardware and software to support these specific types of workloads. Actually, in public cloud, the offerings are generally available to all. Anyone can access the public cloud. We have some examples of public cloud, which are Alibaba Cloud, Amazon Web Service Cloud, IBM, Google Cloud, and Microsoft Azure. Topic: Private cloud. In the previous lecture, we have discussed about the public cloud, and now we will going to discuss about the private cloud. As we know, private cloud is a cloud computing deployment model, and here the customer controls or own the data center providing cloud services. The private cloud model is a service which provide a distinct, secure, and flexible cloud model. Not like the public cloud where the services are provided over the public network, but here the services are delivered over the firm's network, not on the public network. Private cloud provide consumer to control their own data, and it can be only accessible by the single organization or company, and that leads the fact that organization can operate their data with greater control and privacy. Cloud can be physical or virtual. A physical cloud is where the firms have physical custody of the data center where the cloud is hosted. Private cloud consists of an underlying pool of computing resource which will provide computing power as services within the virtual environment. A virtual private cloud, or we can call it as a VPC, is where cloud provider dedicate a set of computing resources for a specific customer, and VPC uses virtual private network or VPN approach to deliver cloud services over the customer's network. The private cloud is much more efficient cloud computing deployment model, and in the private cloud your data is much more secure, as you can see here. So the VPN or virtual private network allows consumer to extend their network to outside data centers using internet connections. And in the data center, the firms does not own or has the custody of the computers. With the help of VPC, cloud provider has control of the data. We have some example of private cloud that are Amazon, IBM, Azure, Google. Here we have some small difference between public cloud and private cloud. In the public cloud, virtualized resources are shared publicly, and in the private cloud, it is privately shared the virtualized resources. Public cloud supports multiple customer, and if you see in the private cloud, it only supports the dedicated customer. Public cloud supports internet connectivity, and in the private cloud, connectivity is over the internet, fiber, or private network. Public cloud is best suited for less confidential information, and the private cloud is suited for secure confidential information and the core system, as the private cloud is much more secure than the public cloud. See you in the next lecture. Topic: Hybrid cloud. In the previous lectures, we have discussed about public cloud and private cloud, and now we will going to discuss about the hybrid cloud. Hybrid cloud is a combination of private and public cloud, or we can say that the function and services provided by the hybrid cloud lies between public and private cloud. It can share the workload between these two clouds, which make it more flexible. And there are more data deployment options in the hybrid cloud as compared to public and private cloud. The private components of hybrid cloud are typically commercial hardware that have hypervisor installed to manage the private cloud services. And in the hybrid cloud, they do not have to provide the complete access to your data. The company using the hybrid cloud computing do not have direct control over its architecture. Combining public services with private clouds and data center as a hybrid is a new definition for cooperative computing. Hybrid cloud has the goal to combine services and data from variety of cloud models to create a unified, automated, and well-managed computing environment. As per the changes in cost and cloud computing, the workload is allowed to move between the private and public cloud. Hybrid clouds provide businesses with greater flexibility and more data development options. And if there is any fluctuation between computing and processing demand, then it will be provided the business with the ability to predict their infrastructure, which will be able to handle the overflow. We have some example of the hybrid cloud, which are Amazon Web Services and Microsoft Azure. Due to the versatile nature of hybrid cloud, it is very tough to identify that which cloud are hybrid cloud or which are not. So we have created some points. With the help of this, we could better understand which are hybrid cloud and which are not. First, a cloud which are hybrid. If organization or company uses public development platform that send data to private cloud or data center based application, then it would be the hybrid cloud. Other, if business process is designed as a service so that it can connect with environment as though they were a single environment, then it will be hybrid cloud. When organization profits a number of software as a service application and moves the data between private or data center resources, then it would be hybrid cloud. So you could better understand from this point that which are hybrid cloud. So now the cloud which are not hybrid. First, if a company is using software as a service application for the project, but there is no movement of the data from that application into company's data center, then it would not be the hybrid cloud. Other, if a few developers in the company uses public cloud services to prototype a new application that is completely disconnected from the private cloud or the data center, then it would not be the hybrid cloud. So from these points, we could better understand that which are hybrid and which are not. So see you in the next lecture. Topic: HPC Cloud. In the previous lectures, we have discussed about public cloud, private cloud and hybrid cloud, and now we will going to discuss about HPC cloud or high performance computing cloud. As the name high performance computing cloud has become popular offering platform of cloud computing providers. HPC or high performance computing enables user to solve complex computationally demanding business, engineering and scientific problems through computer modeling, simulation and analysis. HPC is typically used to solve advanced problems and performing research activity through computer modeling, simulation and analysis. HPC is actually an architecture of arrayed computers or processor. The architecture run together in cluster. A cluster is a group of computers acting as one. HPC uses parallel processing technique for running advanced application efficiently, reliably and quickly. HPCs use supercomputers and parallel processing technique for solving complex computational problems. And most of the users of HPCs are scientists, engineers, academic institutions, military, and all. Architectures can run about quadrillions of calculations per second. A laptop or computer with 3 GHz processor can perform around 3 billion calculations per second. As technologies like IoT, artificial intelligence, and 3D imaging grows, the size and amount of the data that organizations have to work with also grow exponentially. For many purposes, such as live streaming of sport, tracking a developing storm, testing new products, we use high performance computing cloud. There are three components of high performance computing cloud, which are computing, data storage, and networking. The cloud's flexibility and elasticity supports quickly to build a cluster and dynamically adding to cluster if required. Cloud computing provides an ideal model for HPC. The cloud also provides network and storage. So see you in the next lecture. Topic: Big Data Cloud. In this lecture, we will going to study about Big Data Cloud. A big data is the large set of data which will process to extract necessary information. It can easily deliver a solution to store and analyze big data sets. Big Data Cloud is a large set of data which process to gather information from data set. Consider any organization where huge amount of data is generated every second and it need to be processed. So big data will gather and store and organize the data which will be further analyzed by the data analyst. And for that, the data analyst requires large amount of data storage and high performance processing. In Big Data Cloud, cloud can deliver a solution to store and analyze big data sets. So, cloud solution easily scale up or down as the needed to accommodate the needs of the data to be analyzed. Here, big data breaks a large amount of data and distribute it across different computer systems where the data will analyze and process. And hence, the cloud clusters are dynamically implemented to well process the big data sets. In the big data cloud, there is a term known as data warehouse. And the data warehouse is an electronic system that gathers the data from wide range of sources within the company and then use that data to support management in decision making. So, the concept behind the data warehouse was created to shield users from bad performance cost during analyzing data. In the big data cloud, when the users are not connected to the system, the processing of data is scheduled to run off, and the processed data are then stored in the data warehouse for reporting. In the big data cloud, cloud's flexibility provides an efficient solution for data reporting. Now, we have data service examples which are Amazon Redshift, Data Lake Analytics, Google BigQuery, Cloud Data Flow, and IBM Watson Data Platform. See you in the next lecture. Topic: Microsoft Azure. In the previous lectures, we have discussed about cloud computing models, cloud computing deployment models, and now from this lecture, we will going to discuss about cloud computing providers such as Microsoft Azure, AWS, Google Cloud Platform, Salesforce, IBM Cloud, and Alibaba. So first, Microsoft Azure. Azure is a cloud computing platform that allows you to access and manages the cloud services provided by the Microsoft. To get access to these services, all you need to have an internet connection and ability to connect Azure portal on azure.microsoft.com. Azure offers services such as software as a service, platform as a service, and infrastructure as a service. It provides more than 200 services such as development, DevOps, mobile desktop, backup, virtual computing, storage, database, AI, blockchain, and more. Azure offers operating in Linux computing as well as Windows operating systems. It also follows pay-as-you-go model. Another benefit of Microsoft Azure is the number of data centers across the globe. It has 42 Azure data centers around the globe, which is the highest number of data centers for any cloud platform. Running virtual machines in cloud is one of the most popular uses for Microsoft Azure. Interestingly, 80% of Fortune 500 companies uses Azure services for their cloud computing needs. And hence, Microsoft Azure is from the top leading cloud computing providers across the globe. Topic: Amazon Web Services. Amazon Web Services or AWS is a cloud computing services offered by the Amazon.com. AWS is one of the top leading cloud computing providers in the world. AWS platform offers flexible, easy to use and cost effective cloud computing solution to the customers. It also includes infrastructure as a service, platform as a service, and package software as a service offerings. It offers pay-as-you-go model, computing services, including virtual services, APIs, storage, networking, database, DevOps, blockchain, AI, IoT, and many more services. We have the popular service offered by the AWS, that is Amazon EC2 or Elastic Cloud Computing, which has been used by the governments, Netflix that we see, Airbnb, and other popular applications. EC2 provides services include virtual desktop, clustering, networking, and many more. Today, AWS is spread across the globe and more than 100 services are provided by the AWS. Here, we have the page of the Amazon Web Services Management Console, and here we can see the wide range of services offered by the AWS. The featured services such as Amazon EC2, Amazon S3 for storage purpose, Amazon Aurora, Amazon DynamoDB for the non-SQL database, Lambda, Lightsail, and many more. And the AWS offers the services in the different fields such as the machine learning, IoT, game tech, and user computing. And hence, Amazon Web Services is one of the top leading cloud computing providers across the globe. See you in the next lecture. Topic: Google Cloud Platform. Google Cloud Platform or GCP is the brand of cloud computing offered by the Google. The Google Cloud Platform provides cloud services such as infrastructure as a service, platform as a service, and function as a service customers. This platform provides various services like compute, storage, networking, big data, and many more that run on the same infrastructure that the Google uses internally for its end user. Today, Google Cloud Platform is one of the top cloud computing providers and that expanding across the globe. The reason behind this is the wide array of services it offers to its users. Google lists over 100 products in their brand, including application development, networking, storage and database, Internet of Things, artificial intelligence, API, data analytics, and many more services. Google Cloud Platform has core cloud computing products which includes Google Compute Engine. Google Compute Engine, which is an infrastructure as a service offering that provides users with virtual machine instances for workload hosting. Second, Google App Engine. Google App Engine, which is a platform as a service offering that gives software developers access to Google scalable hosting. Developers can also use the Software Developer Kit or SDK to develop software products that run on App Engine. Google Cloud Storage. The Google Cloud Storage, which is a cloud storage platform designed to store large and unstructured data set. Fourth, Google Container Engine. Google Container Engine is a system for Docker's container that runs within Google's public cloud. Here, Google Cloud Platform services are continuously evolving and Google simultaneously make changes or introduces or discontinues the services based on the user's demand. In the Google Cloud Platform, we can say that it is near about same to the Amazon Web Services. See you in the next lecture. Topic: Salesforce. Salesforce is a company which offers customer relationship management solution that bring companies and customers together. Salesforce is a cloud computing software as a service company that specializes in CRM or customer relationship management. This company is best known for CRM product, which is composed of Sales Cloud, Marketing Cloud, IoT Cloud, App Cloud, and many more. It has expanded its offering to include many other cloud services, including Platform as a Service, Lightning, Force.com, and other offerings. Salesforce Services allows company businesses to use cloud technology to better connect with the customers, partners, and potential customers. Companies uses Salesforce to understand their customers and connect with them on the variety of level and help grow their customer base. Salesforce has expanded to other software as a service offering includes first Community Cloud, which is a collaboration product for customer. Second, Work.com, a social network aimed at improving the lives of customers' employees. Third, an online app store called as App Exchange. Fourth, software as a service help desk offered as Desk.com. Blockchain offered through CRM, Salesforce API, and many more services. It also provides Marketing Cloud that offers social media, digital, and other marketing services. See you in the next lecture. Topic: IBM Cloud and Alibaba. In this lecture, we will going to study about IBM Cloud and Alibaba. So first, IBM Cloud. IBM Cloud is one of the cloud computing providers which has different manifestation over the decade. Today's IBM Cloud emerged from several decades of central mainframe offering. The IBM Cloud Platform combines platform as a service with infrastructure as a service to provide an integrated experience to the customers. Its offering include infrastructure as a service, software as a service, private cloud, virtual cloud, and hybrid cloud. The IBM Cloud offers the typical virtualization services and offers its product as a solution for DevOps. Data analytics is one of the major offerings by the IBM Cloud. The IBM Cloud makes use of open standard including open source software as a part of its solution. The IBM Cloud does not offer a single console as its cloud offerings are so numerous. Alibaba. Alibaba also offers cloud computing. Alibaba offers pay-as-you-go model computing services including virtual servers, API, storage, networking, database, DevOps, blockchain, AI, and more. See you in the next lecture. Topic: Virtualization in cloud computing. In this lecture, we will going to see about virtualization in cloud computing. Virtualization is a very important factor in the cloud computing. Virtualization in cloud computing is creating a virtual platform of server operating system and storage devices. This will help the user by providing multiple machines at the same time, and it allows the sharing of application to multiple users. Cloud virtualization also manages the workload by transforming traditional computing and make it more scalable, economical, and efficient. Virtualization in cloud computing rapidly integrating the fundamental ways of computing, and one of the most important feature of virtualization in the cloud computing is that it allows the sharing of application to multiple customers and companies. Here, cloud computing provides services and application over virtualized environment, and that environment may be either public or private. In virtualization in cloud computing, customers can maximize the resources and reduces the physical systems which is in need. There are other different type of virtualization in cloud computing, which are operating system virtualization, hardware virtualization, server virtualization, and storage virtualization. Let's see them all in more detail. First, operating system virtualization. In operating system virtualization in cloud computing, the virtual machine software installs in the operating system of the host rather than directly in the hardware system. The most important use of operating system virtualization is for the testing application on different operating systems. Here, the software is present in the hardware which allows different applications to run. Hardware virtualization. In hardware virtualization in cloud computing, use the server platform as it is flexible to use virtual machines rather than the physical machines. In hardware virtualization, virtual machine software is present in the hardware system, and hence it is known as the hardware virtualization. It consists of the hypervisor which is used to control and monitor the process, memory, and other hardware resources. After completion of hardware virtualization process, the user can install different operating system in it, and with this platform, different application can be used. Third, server virtualization. In server virtualization in cloud computing, the software directly installed on server system and used for physical server can divide into many servers on demand basis and balance the load. With the help of software, the server administrator divide one physical server into multiple servers. And this is the story of the server virtualization. Fourth, storage virtualization. In storage virtualization in cloud computing, a grouping is done on a physical storage which is from multiple network storage devices. This is done so it looks like a single storage device. It can implement with the help of software application, and storage virtualization is done for the backup and recovery process. It is a sharing of physical storage from multiple storage devices. Benefits of virtualization in cloud computing. First, security. During the process of virtualization, the security is one of the most important aspects, and the security is provided with the help of firewalls, which will help to prevent the unauthorized access and will keep the data confidential. With the help of firewall and security, the data can be protected from harmful viruses and cyber threats. Second, flexible operations. With the help of virtual network, the work of its professional is becoming more efficient. The network switch implement today is very easy to use, flexible, and save the time. With the help of virtualization in cloud computing, technical problems can be solved in the physical system. It eliminates the problem of recovering the data from crashed or corrupted devices, and hence it saves the times. Third, economical. Virtualization in cloud computing save the cost of physical systems such as hardware and servers. It stores all the data in the virtual servers, and that is quite economical. It reduces the wastage, decreases the electricity bill along with the maintenance cost. Due to this, the business can run multiple operating systems and applications in a particular server. Fourth, transfer of the data. The data can transfer to the virtual server and retrieve anytime. The customers or cloud provider do not have to waste the time finding out hardware drives to find the data. With the help of virtualization, it will very easy to locate the required data and transfer them to allocated authorities. This transfer of the data has no limit and can transfer to the long distance with the minimum charge as possible. So this kind of benefits are provided by the virtualization in cloud computing. So see you in the next lecture. Topic: bare metal computing. In this lecture, we will going to see about bare metal computing. So a bare metal is a computer system without the base operating system or installed applications. The term bare metal is referred to the hard disk, which is the usual medium on which the computer operating system are installed. Bare metal computing is a hosting strategy where the operating system are installed on the physical hardware. In the bare metal computing, a virtual machine is installed directly on the hardware rather than the hosting operating system. The bare metal cloud server do not run on the hypervisor, and hence there is no virtualization, but still be delivered by the cloud-like service model. The bare metal cloud provides a way to substitute virtualized cloud services with a dedicated server environment that eliminates overhead of the virtualization without sacrificing flexibility, scalability, and efficiency. And hence, the bare metal computing is highly stable, durable, and reliable. In this computing, all the software is installed on the native hardware or bare metal. A laptop native hardware and software is a good example. Most mobile devices operated in this way. Here we have example of software user and bare metal associated with and the network here. You can see how the bare metal, it might be the Raspberry Pi, is communicating over the network to the one user. And this is a perfect example for the bare metal computing. See you in the next lecture. Topic: virtual machine. In this lecture, we will going to discuss about virtual machines. So, a virtual machine is a virtual representation of a physical computer. By running the virtual machine, it makes better use of existing hardware. This allows many instances of operating system and software to run on the same bare metal hardware. And about the bare metal, we have discussed in the back lecture. Virtualization make it possible to create multiple virtual machines, each with their own operating system and applications, and all this on a single physical machine. Virtual machines cannot interact directly with the physical computers. Instead, it needs lightweight software called as the hypervisor to coordinate between the virtual machines and the physical hardware. The hypervisor manages access to the physical hardware for each virtual machines. This hypervisor allocates computer resources to the virtual machines, and that computer resources can be the processor, memory, and storage. Here, in this figure, we can see that the hardware is not just supporting small set of users, but the large set of operating system or user, and this is managed by the software product called as the hypervisor. Virtualization plus cloud allows the company to manage hardware like a software. When the virtual machine is running and program or a user issues an instruction that requires additional resources from the physical environment. Here, the hypervisor schedules the request to the physical system's resources to get virtual machines, operating system, and application can access the shared pool of the physical resources. With their own IP address and host ID, multiple copies of virtual machine images can be made. And in the virtual machines, virtual network allows to communicate, and that is identical to bare metal machines. See you in the next lecture. Topic: Docker. In cloud computing, virtual machines are not the only hosting scenario. Docker is another one. Docker is a product that can be downloaded, and it's an open source system of software container. It is a software platform that allows you to build, test, and deploy applications quickly by using these containers. Docker is a platform as a service product that provides virtualized operating system environment that called as the containers. So all the applications are installed in this container. These containers help application to work while it's being shifted from one platform to another, like migration from developer's laptop to staging to the production. Docker's container are hosting and deployment strategy. Docker does not provide full virtual machines. However, Docker does use virtualization. Docker containers require the operating system to be run on, and hence they cannot be run on their own. All the Docker containers run on a single operating system kernel called as the Docker engine, and this container are dependent on the single operating system kernel. These containers are much simpler than a full virtual machines. Hypervisors do emulate actual hardware system, but they also have a lot of system requirements. There are online services like Azure, AWS, Google Cloud Platform, and that present for the enterprises in today's date. Here, Docker containers provide 100% predictability on how an application will be installed and how will it be executed. Here, we have virtual machines and containers. Here, in virtual machines, the application can be installed on the virtual machines. We can see here App 1, App 2, and App 3 are running on their own virtual machine, which are VM1, VM2, and VM3. These virtual machines can drip slightly, so once they open running, they can actually become completely independent computers. And hence, sometimes it can be hard to keep them like this. Here's the hypervisor that managing these three virtual machines on a physical server. But there is a lot of complexity here because one or three applications are running on a very complex infrastructure. And if we see about the container, then the Docker engine and operating system are managing this application on this physical server. All these containers uses the Docker engine and able to provide virtual hosting environment which will guarantee that this application will run on the same way, and once the Docker deployment pattern is established, it can be repeated and automated. And that's all about the Docker. See you in the next lecture. Topic: serverless computing. In this lecture, we will going to see about serverless computing. Serverless computing is an extension of function as a service, and hence all of the large cloud provider offers a form of serverless computing. Serverless computing is a cloud computing execution model where the cloud provider runs the server and dynamically manages the allocation of machine resources. If we see the word serverless means no server, it allows you to build and run application and services without worrying about the server. It eliminates infrastructure management tasks such as server, operating system, maintenance, and all. Customers can build them nearly any type of application and everything required to run and scale customer application with high availability is handled for the customers. The cloud provider manages the computing resources in a way that they can be delivered in a dynamic fashion. Serverless computing offers pricing based on runtime computing time used and do not charge for the idle time. Nowadays, offering of serverless database and serverless storage have become available. So, serverless database products are generally depend on popular databases such as MySQL. Serverless computing provide advantages with respect to cost and software deployment. Here, serverless computing is execution only. Data is not stored with serverless offering. Performance can be slow with serverless computing as there is startup time involved with serverless computing and resources are limited. Serverless computing is often based on provider standard and therefore mobility can be the problem. See you in the next lecture. Topic: distributed applications. Here in this video we will going to discuss about distributed applications. So, a distributed application are the software or the application that runs on the multiple computers within a network at the same time, and it can be stored on the server or with cloud computing. It's not like the other traditional application that run on the single system. Distributed application run on the multiple systems simultaneously for a single job or single task. Distributed application allows multiple users to access the application at the once. Here in the IT field, IT professionals choose to store distributed application in the cloud because of the cloud flexibility and ability to handle large application or the workload. Many of the enterprises can choose to use container technology. And as we discussed in the previous lecture about the Docker, so the Docker is the container technology. And the work of the container technology is to package and deploy distributed application. And as the enterprises uses the container technology, the work of the containers is to build and run the distributed applications and as well as to share the infrastructure. Here, distributed ledger technology or DLT have created an operating environment which is equivalent to the operating network. DLT include blockchain technology, and the blockchains are DLT, but not all the DLT are the blockchain. This is the very important concept about the DLT and the blockchain. DLT is based on the network of the computer, what we have called it as the nodes, and the nodes are able to store the data in a way that it is immutable, and that immutability comes from the concept of hash. Hashing data convert it to a string of a fixed length, and once the data is hashed, the hash is stored on the node. Cloud is an ideal environment for managing DLT and blockchain nodes. Obviously, several nodes can be brought up within a cloud to manage that operating network. Nodes can be deployed as needed. Many cloud providers already offers DLT and blockchain services. The DLT node can also run applications that called as distributed application or DApps. DApps can never be changed, they exist as a part of the network. DApps can run as a web or mobile application and are the basic of the new Internet of Value. And that's all about distributed application. Topic: Cloud computing with AI. In this lecture, we will going to see a little bit about cloud computing with AI or artificial intelligence. So, artificial intelligence or AI is a cloud computing strategy that processes the processing data for computer programs to make the decision. In simple, it is the capability of the machine to take their decision by their own. Artificial intelligence and cloud computing have merged to change the lives of millions. Digital assistants like Siri, Google Home, and Amazon Alexa blend artificial intelligence and cloud computing in our lives every day. Artificial intelligence systems require large amount of current data for making effectively correct decisions. If any task program is running, then AI process data and make correct decision. And then computer programs learn and store the correct decision, and after that, if the same program is run, then the AI will make the correct decision. As the artificial intelligence system required large amount of current data, it required large amount of data storage too. Cloud provides an excellent environment that required for the artificial intelligence such as data storage, retrieval, and processing. See you in the next lecture. Topic: Cloud computing with IoT. In this lecture, we will going to see about cloud computing with IoT or Internet of Things. So, before moving forward, we should know what is IoT. The Internet of Things is a system of corresponding billions of physical devices all around the world, which are all provided with a unique identity and all are connected to the internet with sharing and collecting data without requiring human to human or human to computer interaction. Little bit confused? Let's see with the example for better understanding the IoT. Consider a man whose name is John and he is the manager at the pharmaceutical company. And as we know, pharmaceutical company manufactures the medicines. So, during manufacturing these medicines, it is very important to keep the temperature from minus 40 degrees Celsius to minus 30 degrees Celsius. And if the temperature crosses this threshold level, then the quality of medicines will not be maintained. And as per the government regulation, all the medicine must be discarded, and this will lead the huge loss for the pharmaceutical company. And monitoring this system manually by the human is very hard. So the company set up the hardware which consists of the sensor and Wi-Fi module, and that is connected to the cloud. The work of this hardware is to monitor the system and any unwanted stuff is recorded. Then the hardware uses the cloud to inform the user or the John via text or email. And as the John has received the information, then he will work on the technical issue and this will save the huge loss of the company before it's happened. And from this example, you could better understand how the physical devices is connected over the cloud and used for sharing and collecting the data. And that's what the IoT is. From now, I think you could better understand about IoT. So, with the greater uses of IoT in cloud has acted as an impulse for development and deployment of scalable IoT application and business models. Here, the cloud computing and IoT both are associated with each other, and future internet technologies with one providing the other a platform for the success. With the help of cloud computing, the speed is increased and agility in making resources is available to the developers. As the Internet of Things uses cloud computing, the large amount of data is produced, and therefore it becomes difficult for enterprises to manage the flow and store all of the data. And there's come the cloud computing. It helps the companies with its different models and implementation platform to manage all the tasks. And all this helps the company to enhance overall efficiency. Internet of Things helps in increase the performance of services, follows the pay-as-you-go model, which is the great stuff. It provides infrastructure and it increases the scalability of the services provided by the companies. And that's all about cloud computing with IoT.